Assalamualaikum. Today, our group is going to present to you about home surveillance automation system. So this is our group members. This is the Raspberry Pi 3B Plus specification. It uses Broadcom BCM2837B0 processor. It uses 1GB LPDDR SD RAM for the memory. For the networking, it has Wi-Fi, Ethernet, and Bluetooth. For the storage, it uses micro SD slot. For the port, it uses 4x USB 2.0, 40-pin GPIO header, full-size HDMI, 3.5mm audio video jack. For power, it uses 5V/2.5A via micro USB and PoE support with PoE head. For physical dimension, it is 85.6mm by 56.5mm and weight 50 grams. Part A. Booting Raspberry Pi. Okay, first we are going to install the OS into the SD card. So this is the SD card. Next, we're going to open Google and we are going to search a Raspberry Pi Imager. So here you just download the software. Next, we are going to run the installed software. So first we're going to choose what type of Raspberry we use. We use Raspberry Pi 3. Next, we are going to choose the OS. We are going to pick the recommended one. Next, we are going to choose the storage. We're going to choose the SD card that we put before. And then we click yes. So this is the content of the ISO. All of this that we have saved in the SD card. So after we check that, we're just going to eject the SD card. Next, we're going to take the SD card and put it in the Raspberry Pi. So next, you need to connect the power supply and also the HDMI. And to run the Raspberry Pi, you need to have a keyboard and also a mouse. Okay, next we are going to move on to section B, watching the Raspberry Pi virtual memories. First, we open the terminal, and then we're going to write the VM stack. So the VM stack is going to display one line of data and two lines of column header. So the VM stack utility summaries the current state of the Raspberry Pi virtual memory system. The command can be repeated after an elapsed time interval and limited to a specified count by using two optional parameters. So we are going to write VM stack is 2 seconds, going to be repeated for 5 times. So as you can see, the data is being repeated for 5 times with the get time of 2 seconds. Okay, next we're moving on to part C, which is the programming GPIO. So first we need to find out what version of Python that we use. So we're going to write Python. So here, we are using Python 3.11.2. Next, we need to update the Raspbian and Python. It is essential to regularly update Raspbian to ensure you have the latest software and security patches. Updating also ensures you have the latest version of Python. Command to update and upgrade is the sudo apt-get update and sudo apt-get upgrade. This command updates the package list and upgrades all installed packages to their latest versions. Next, installing the Python GPIO library. The GPIO is required to control the GPIO pins using Python. This is a one-time setup step. Command to install GPIO library is the sudo apt-get install rpi.gpio. This command installs the GPIO library necessary for controlling the pins on the Raspberry Pi. Next, importing the GPIO library in Python. Command to install the GPIO library are import rpi.gpio/gpio. This line imports the GPIO library, giving your script access to GPIO functions. Next, setting GPIO pin layout. The command to install GPIO library is gpio.setMode in bracket gpio.baud. This line sets the pin numbering to match the layout on the board. For the alternative mode, it is gpio.setMode in the bracket gpio.bcm for Broadcom SoC pin numbering. Next, programming GPIO pins as input and output. So it's basically the same for the two. As you can see, we would like to set pin 12 as the output. So what we need to do is we need to write the code of gpio.setup in bracket 12, gpio.out and configure pin 12 as an output pin. It's the same as input and except we change the out to the in to configure pin 12 as an input pin. So now we will continue
on section D on how to build a simple circuit and make LED blinking by using Raspberry Pi. So the component that we're going to use is a small blue LED and 200 ohms of resistor, and also the breadboard, and also jumper wire, male-female jumper wire. So now we will continue on section E, which is example 2 of using output. That just now we have built our simple circuit, so now we will control the LED by using Python script. So this is the script looks like, and on the first part, importing libraries. Import rpi.gpio as GPIO. This import the rpi.gpio library, allowing us to control the GPIO pins. And then import time. Import time is this import the time library which we will use to create the delay. And then second one is to setting up the GPIO mode warning. So GPIO.set mode in bracket GPIO.port. This set the pin numbering mode to use the physical pin number on the GPIO header. And then GPIO.set warning, and in bracket false is this disable warning that might pop up if the GPIO pins are already in use to configure. And then we need to configure the LED pin. So we're using LED in the GPIO pin 7, so we put it as the name. And then GPIO.7 GPIO.setup in bracket 7 GPIO.out. This configures the pin as the output pin. So now for LED blinking, print bracket blinking is to print the blinking to the console to indicate the blink process is starting. For X in range 0,59 seconds is the loop where it runs 16 times to blink the LED. On GPIO.output, LED 1 is to turn the LED on. And then time.sleep in bracket 1 is to keep the LED on for 1 second. And then for LED 0 means LED off, and time sleep 1 is to keep the LED off for 1 second. And then cleaning up, so GPIO.clean up is to reset the GPIO pins to their default state, ensuring that relay are properly released and no longer in use. So this is the result for the LED blink output. So we have successfully built a simple circuit by using Python script to make the LED blink. So now I will continue on section F, which is example on how of using in the input. So we will be using a Python. Suppose we will be using Python and understanding on how to deal the problem of the floating state and using pull-up resistor. But in our video, we are using yellow jumper wire as our push type button or button, not as a button. So before that, to understand the float states and pull-up resistor, when we use a pin for input such as reading the states of button, the pin can sometimes be in an uncertain state known as a floating. This happens because input pin can actually have 3 states, which is on, off, and also floating. This variable input detection, we want the Raspberry Pi to detect only true or false states. To solve the problem, we use pull up or pull down resistor. This resistor ensures that the pin is in a finite state when the button is not pressed. The Raspberry Pi has internal pull up and pull down resistor that can be enabled through the programming. So for the Python script, first is importing libraries. Import rpi.gpio as GPIO is to import the rpi.gpio library, which allows us to control the GPIO pins. And then import time is to import the time library, which we will use to create the delays. And then second one is to setting up the GPIO mode or pin and pin, which is GPIO.set mode in bracket GPIO.PCM is to set the pin numbering mode to BCM with or Broadcom SoC channel numbering. And then below is to configure the GPIO pin 4 as an input pin with an internal pull-out resistor. The pull-out resistor ensures that the pin is in high state, which is in 3.3 volt when the button is not pressed. To starting the program, print start is to print start to the console to indicate the program has begun. And then push this button. This prompt the user to press the button. And then detecting the button pressed in the loop. The words of while true in the code is to create the infinite loop to continuously check the button states. The button underscore press. equals to GPIO dot input in bracket pin, this read the state of the pin for it will be false when the button is pressed because the pull up resistor brings the height when not pressed. And then if button underscore press equals to false is for if the button is pressed, it reprints ding dong button pressed and waits for 1 second. Else the button is not pressed and it prints push this button and it will wait for 1 second. To cleaning up, GPIO to clean up in bracket is this line to reset the GPIO pins to the default states, ensuring they are properly released. So by using a pull up resistor, we ensure that our input pin it is in clear state, either high or low. Avoiding these floating states, this allows to reliable detect button press. So this is the result when we are using the button. We will continue on section G, which is Wi-Fi on the Raspberry Pi. So we gonna write the code if config eth0 and yeah. So this is the result. For the if config eth0. And for now we're using Wi-Fi internet. So result for if config eth0. For now we use Wi-Fi internet. If we use wired internet, it is better configuration utility rather than Wi-Fi. So now we just can do this and cannot continue for the wired internet and cannot finish the task of in the section G, because we are using Wi-Fi. So that's all for me. Thank you.
Okay, now I will demonstrate for our project. Our project is home surveillance automation system using Raspberry Pi. So here we will use this coding. And for this project, we use input and output. For output, we use LED and buzzer. Actually, they connect the same pin. But in coding, we mention just LED. But I connect the LED pin with the buzzer. And then for the input, we use sensor motion. Okay. Now this one, the coding. Okay. If you see over here, from GPIO 0 import LED and motion sensor from signal import pause and import time. So for this one, this is about necessary libraries. So for GPIO 0 is a library for interfacing with the GPIO pin on the Raspberry Pi. We import LED and motion sensor to control the LED and read input from the motion sensor. And then signal pause. Signal pause is used to keep the script running. And then time is used to add any delay in script. Okay, and then over here you see I have LED in 27 and motion sensor 70. So if you see over here, we declare the LED small calculator as 2417, that GPIO pin. Okay, and then for motion sensor we use 17 GPIO. And then for print start, if we run, it will start with display start. Okay, that means the program is running. Okay, next this one. Okay, this one that we define a function, a motion detected, that we call when motion is detected by the PIR sensor, then motion sensor, and function will print motion detected at the terminal, and the LED will on. Also, because we connect the same pin to the buzzer, so the buzzer also on, and the delay for the output is 33 seconds. Sorry, 3 seconds proceeding before proceeding, and then let's define this one and no motion. This one, if no motion detect, the display will display no motion and the LED will off. Then over here, the motion detection null. So this one, we attach our previously defined function to them when underscore motion and when underscore norm underscore motion event of the PIR sensor. This is tell our script what to do when motion is detect and when it's stop. And then the last one is keep the script running. So this one that we mentioned that import from signal import OS. So this one the function for in the coding. So keep the script still running, and then we demonstrate. Okay. We're running the program, so you can see over here it will start with display 5, so send the encoding over here, and then if the motion detect something or motion, that will display motion detected, and then LED will hide for 3 seconds. But in here we connect the buzzer with the same pin LED. Okay. Here, okay. So we hide the number, we hide. Okay. And then no motion detect. Okay. And then okay. If now display, so that our demonstration, that you can see every time the sensor detect motion, will display motion detected. After 3 seconds, no motion. If still have motion, they will repeat again, motion detected and then motion, and also the LED will hide again and then repeat again. So that's it for the demonstration. Thank you.
Okay, now let's understand 5 frequently asked question. Question 1. How do you set up the recipient OS on the Raspberry Pi?
The question 1 answer is download the recipient OS image from the official Raspberry Pi website first. Use Balena Etcher to write the image to an SD card. Insert the SD card into the Raspberry Pi and power it on. Follow the on-screen instruction to set up the operating system. Then update the system with the terminal.
Question 2. How do you connect the PIR motion sensor and LED to the Raspberry Pi GPIO pin?
The question 2 answer is connect the VCC pin PIR sensor to the 5V pin on the Raspberry Pi. Then the GND pin to a ground pin and the out pin to GPIO pin 17. Then need to connect the LED, so the anode of the LED throw a resistance to GPIO pin 18 and the cathode to a ground pin.
Question 3. How can you test the system to ensure the PIR sensor and LED are working correctly?
The question 3 answer is we need to double check all connection, then manually run the Python script as the code I showed. Then we move in front of the PIR sensor. The LED should light up and the controls should print motion detected.
Question 4. How can you configure the Raspberry Pi to run the Python script automatically on startup?
For answer the question 4, we need to open the CROT tab editors and add the following line to the file.
because this is ensure the script run every time the Raspberry Pi moves. The last question, what are some common issues and troubleshooting steps if the LED does not light up when motion is detected? The first common issue is incorrect wiring. We need to ensure all wires are connected to the correct GPIO pins. Second, permission errors. So, need to solve it, run the script with sudo if necessary. Third, library installation issue. To troubleshooting it, make sure the required libraries are installed. The last one common issue is script error. We need to solve it, check for syntax or logical error in Python script and ensure the GPIO mode match to the wiring. That's all for our project, so thank you everyone for watching. Bye bye.